All right, so I have a function. I have the first derivative. I have the second derivative. And the question is, I assume based on the function, we can all find those two derivatives. All right, we're pretty good at that stuff. I want to know about the critical points, and I want to know, are the critical points min, max, or neither? So I want to know the critical points and whether they're min, max, or neither. In the interest of time, we'll keep going. So you have the first derivative. So the first thing you got to know is, well, critical points happen when f prime equals 0, right? Or when f prime is undefined. So we got to be careful here in case I give you a rational function. But we recognize the derivative is a polynomial, x cubed 6x squared 9x is continuous and differentiable everywhere. So the first thing I do is we factor, and I'm pretty sure it's x times x plus 3 squared if I did this right. And I look at this and how many critical points are there? Well, 2 distinct. Technically 3, but 2. I agree. So we're going to go with 2. And if you're wondering on the video why 3, negative 3 is an answer 2 times. Multiplicity from pre-calc for you guys who are not recalling. So I would say f prime equals 0 at x equals 0 and negative 3. All right. Now my million-dollar question is, are they mins or maxes? All right. A couple ways to do this. You could make a table, or you could plug values. I think tables are easier to see. All right, so we'll make a table. You guys ask, and Mr. Anderson will deliver. So we'll make this an object. And we'll get it a little smaller and stick it to the side. We'll do it in green. We'll do it in blue. We'll do it in black. Whatever color works, there goes. We'll do it in black. And I don't care. I'll leave a column for it. There's f prime. And I know at negative 3, it's 0. And I know it's 0, it's 0. And I know I know that there's values here for these because the first function f is a polynomial. There's some values there. I don't know what they are. Don't care. Doesn't matter. I didn't ask what the maximum or minimum was. I asked, is it a max or is it a min? What's happening at those points? All right, so I got to check 3 regions. Here, here, and here. All right. Hopefully, we notice right away that x plus 3, what do we know about x plus 3 quantity squared? Always positive. The only thing that has any effect on this thing is the x. X is negative here, x is negative here, x is positive here. If you take a value, negative 10, and plug it in, you'll get that this is negative. If you take a value in here, say negative 1, in between negative 3 and 0, and put it in here, you'll get a negative. If you pick a value to the right of 0, like 2,742,000, put it in here. It's a positive. All right? So what we know, and I love this problem, and we should remember this from pre-calculus when it has x, when we set our zeros from last year. Maybe this is a good reminder that we know this sucker bounced. All right? It either bounced like that or it bounced like this because of the square on the x plus 3. We might have forgotten that. But it doesn't matter because we can prove it with calculus. And it goes negative to negative, so is it a max or min? Nada. Not a max or a min. No sign change. Not either. And what rule is it? Not either by first derivative rule. Oh, alright. Alright. Here it goes negative to positive. I can picture that in my head. That's a local min. Alright, there we go. We would actually be able to find the second derivative here, right? And do concavity. One thing we know for a fact, without even taking the second derivative or thinking about it much, I'll do this in red. If I put f prime prime in here, at this point, if it's a local min, I guarantee the derivative of the second derivative has to be positive at 0 at least. Because that's the second derivative rule. Again, these are both located in your book in section 4.3. These are guaranteed to be on your test. I look up at the problem. Does it factor? Oh, it does factor. Oh, I'm so happy. What a beautiful problem. think I should save this one and use it. Alright. So again, we have regions for finding concavity, okay, based on the second derivative. But I want to keep this video short. This one was about the first derivative rule. Alright. And the first derivative rule says there must be a sign change for there to be a max or min. Alright, so one spot there was no sign change, and the other there was. And the one thing we know is there are two critical points, 0 and -3. And -3 is not a max or a min, and 0 is a local min. Maybe a global min, but definitely a local min.